This is PreCalc 11, Chapter 5.3. This time we're going to be looking at graphing quadratic inequalities in two variables. Now, if you understand the previous section, this one will be easy. If you also know how to graph quadratics, then this will be very easy. Again, we have four forms. Y is less than the quadratic, less than or equal, greater than or equal to the quadratic. And you have to note that this time we're not looking for a domain as we did in 5.1. So read the test questions carefully. And your hint is, are we comparing the quadratic to y or 0? Here's an example. Y is greater than x squared minus 2x plus 8. This factors into y is greater than x plus 2 times x minus 4. And since this is a strict inequality, we graph the quadratic with a dotted line. This means shade above. So we go ahead and shade everything above. And we can determine things by looking at our equation here. We can see that the y-intercept is just -8. Our x-intercepts are from the factored form, so -2 and 4. Our axis of symmetry is between the two intercepts, so this is 4 minus 2 divided by 2. Or you can do -2 plus 4 divided by 2, and that's 1. Our vertex, you can complete the square to find the vertex, or you can just use the axis of symmetry. It's 1, so we plug 1 into this equation. We have 1 squared minus 2 times 1 minus 8. This equals -9. 1 minus 2 minus 8. So our vertex is 1, -9. List 3 points that satisfy the above. Well, we can pick, this is a scale of 2. We can pick 0, 4. We can pick 2, 2. We can pick 2, -2. Or you can just use less thought. And go with 0, 0, 0, 1, 0, 2. Some questions will require you to recall converting quadratic forms. So you'll need to know general. You'll need to know standard, general, vertex, and factored. And other questions will require you using the discriminant, formulas, quadratic formula, etc. So you'll need to review the previous chapters as necessary. So you can see we're building on all our previous knowledge. So here's a problem. The length of a rectangle is 5 times a number. The width is 4 less than the square of another number. The length is greater than the width. Sketch the graph. So let's look at the key items in the problem. This will simplify it. We're looking at 5 times a number. We're looking at 4 less than the square of another number. And we're looking at the length is greater than the width. So we have 5y is greater than w. We know that w is 4 less than the square of another number. So 4 less than the square of another number. And we know the length is greater than the width. So sketch a graph. Let's do the substitution. We have 5y is greater than x squared minus 4. So y is greater than x squared over 5 minus 4 over 5. So first thing, you need to notice that this is in vertex form. Our vertex is 0, negative 4 over 5. So 0, negative 4 over 5. And we use scaled increments. Our number is 1, and we divide it by 5. Our next number is 3 over 5, and 5 over 5. So we're going up by all the odd numbers. So 1 over 5, that's here. Symmetrical on both sides. Now we're going up 3 over 5. That takes us to here and here. And now we're going up 5 over 5. That's just 1 unit. And 7 over 5. So that's about there. And we draw a dotted line. Now, with word problems, you will have restrictions. And our first restriction is the length. The length must be greater than 0. So y is just greater than 0. So we have this restriction where it must be greater than 0. Our other restriction is x squared minus 4 must be greater than 0. So x squared is greater than 4. So this is the absolute value of x is greater than 2. So we have x is less than negative 2, or x is greater than 2. And there we have negative 2 and 2. So we shade above the quadratic left of negative 2, and we shade right of 2 and above the quadratic. We don't shade anywhere in here because we need the intersection. Yes, the here would be above y, but it's within 2. So this is about as complicated a problem as you're going to get. Make sure that you keep the lengths and widths positive, and check your restrictions. And that completes this lesson.